Hello. I hope all of you are doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft, and I'm also an educator at Tree Level. So in this video, what we are going to do is we are going to talk about the concurrency control concept in DBMS. So let's quickly get started. Concurrency control is the management procedure that is required for controlling concurrent execution of the operations that take place on a database. Because let's admit it, if you have a very big database, there's not a chance that you are the only one accessing the database at a time, right? There will be multiple people who will be accessing the database at any particular type of time. So that means there is a concurrent access to the database, which can actually lead to a lot of problems as well. So you need to make sure that you have some management procedures put into place that controls the concurrent execution of the operations. But before knowing about concurrency control, we should also know about concurrent execution first. Okay, what is the meaning of concurrent execution? So in a multi-user system, multiple users can access and use the databases at one time, right? Which is known as concurrent execution of a database. If let's say hundreds of people are accessing a single database at a one point of time, it is known as a multi-user system, and this kind of access of database is known as concurrent execution of the database. It means that at the same database is executed simultaneously on multi-user system by different users. Now, while working on the database transaction, there occurs the requirement of using the database by multiple users for performing different operations. And in that case, concurrent execution of the database is performed. Okay, when you're working on database transaction, there is usually a good requirement, right, wherein you want the database to be able to be accessed by different people for different operations. Some people have the delete access, some people have the update and the select access, and some people just have the access to read the data and not do anything. Okay, and that could lead to concurrent execution on the database that is performed. Now, the thing is that simultaneous execution that is performed should be done in an interleaved manner, and no operation should affect other operation. You remember the ACID properties, right? Multiple executions should get executed in a way that they're not even aware that some other execution is happening, and they feel that they are the only execution that is happening, right? That's what the point says, that you have to make sure that the other executing operations are not effective, and it maintains the consistency of the database. Let's say on a data item X, person A is also trying to deduct 500 and person B is also trying to deduct 400, right? The balance could itself go in negative also if it is not done in the right way. Thus, on making concurrent execution of the transaction operations, there are several challenges that needs to be solved and taken care of before you execute those concurrent transactions. So in a database transaction, there are two operations that we can do, right? We can do read operation, we can do write operations. So there is a need to make sure that these two operations in the concurrent execution scenario are performed like, they're not performed on top of one another, right? They're performed in isolation with each other so that the data doesn't become inconsistent, right? So the following problems that can actually happen with these two operations are: first, WW conflict, which is lost update problems. Okay, so we'll go through, there are three total problems. We'll go through all of them one by one. Now, this problem occurs when two different database transactions perform the read and write operations on the same database items in an interleaved manner, right? Which I was talking about. Person A and person B both is trying to deduct money from a database item X. Okay, and that is, they're trying to do it in a concurrent manner instead of doing one after the other, and that basically leads to incorrect value in the database, hence making the database inconsistent. Let's take an example. So here what you will see is there are two transactions, TX and TY. They are performed on the account number A. So two different transactions, both happening on account A, where the balance of the account is $300. Now at T1, TX is executing and it is reading from data. And at T2, 50 rupees has been deducted, or $50 has been deducted from the A's account. And at that moment itself, now TY also starts executing and it's read the data A. Now this is wrong, right? You deducting some money from the account, right? And here someone else is reading that, I would say, balance itself, which is wrong. They should have both be reading $300. But in this case, TX will read 300, but TY will read 250. Okay. And what will happen is after that, TY will basically add 100 rupees or $100 to that account, which will lead to 250 plus $100. That will lead to 350. Correct. And then that value will get written by TX in the database. Correct. So you can see this is how this is how wrong it is, because the update that we basically did in the account A basically got lost. Right? You can see over here. At time T1, transaction TX reads the value of account A, that is 300. Okay, it is only reading. And at that point, T2, right, what happens at T2, TX transaction basically deducts $50, which leads to $250. Only deducted money and not did any update or write. Alternatively, at that point at T3, transaction TY starts executing, right? And the value of the account was actually 300, correct? So here what happens is, in this case, I think I did one part wrong here. Read A will also read as 300 only. Why? Because so far A has not updated. A has not done the right operation. Okay. So TX will also read 300. Y will also read 300. Why? Because TX has not updated the value in the account. And at time T4, what will happen is the transaction TY basically added 100 to account A. So currently, this A basically has the value 250 and this A basically has the value 400. Okay? Only added but not updated in the database. Now at T6, what will happen is the transaction TX basically writes the value of account A to the database. And what was the value for A for TX? 250, right? So 250 is now updating the value. Now, similarly at T7, TY will also update the value in the database, right? And will basically add $400 in the database, correct? And that means TX value basically got lost. 250 got lost in here because after that Y override the value of TX, right? And basically added 400. Hence, the data becomes incorrect and the data set leads to become inconsistent. So ideally what happened was 50 got deducted, 100 got added. Technically only 50 got added. But what balance did you got? 400, which is absolutely incorrect. Right? So this is a lost update kind of a problem where TX is also doing a write operation, TY is also doing a write operation, and this leads to a write-write conflict. Okay. So this is the example for that. Next, we have a dirty read problem, which is a read-write conflict or a write-read conflict. In the dirty read problem, one transaction basically updates the item in the database and somehow that transaction fails before you actually roll back, the updated database item is actually accessed by another transaction. So you started execution of a transaction, you did some task and then you did something wrong, okay, and you tried to roll back. When you tried to roll back, at that instance itself, someone tried to access the value and then after that you rolled back. So this is dirty read. A wrong value gets readed by another transaction. This leads to a read-write conflict. Take an example. Two transactions, TX and TY, available balance is $300. Read is done, right, by TX, correct? And then $50 got added. So we have 350 and we updated 350 in the database as well, okay? But somehow the server went down, okay? Or some system failure happened. And at that moment also TY read it. So what TY will basically read? 350. But actually after rollback, the balance was again 300. So dirty read, wrong read problem. Let's go over it. So here what we saw was at T1, transaction TX basically had $300. Then it basically added $50, led to 350 and it updated 350 in the account as well. But then there is some failure happened, right? And at the same moment, T4 tried to access. So it accessed 350, right? But then rollback happened and the value basically got back to 300 again. So your TY basically read 350, whereas the balance actually is 300, okay? Leading to a dirty read problem. Next, we have unrepeatable read problem, okay? Also known as the inconsistent retrieval problem that occurs in a transaction where two different read values are read for the same database item. Let's take an example. So two transactions, TX and TY, they are both performing read-write operations, right? And there is an available balance of 300. Read A, okay. At the same time, TY is also reading, so 300, 300 both are reading. Then TY basically did an updation, okay, for adding 100. So this becomes 400. And 400 basically got added after like that, and you read. And then you again tried to read. TX again tried to read. So earlier it read 300 and now it is going to read 400, correct? Let's see what's happening. At the time T1, transaction TX basically reads the value 300. Y also reads the value 300. At T3, Y updates the value and adds $100, leading to $400. Okay. And then at that point, T4 basically updated the value in the database to 400, right? And at T5, now X tried to read again. So it tried to read again at T1 and now it is trying to read again at T5. Okay, and now it will read as 400. It means that within the same transaction, let's say I am doing some transactions where I need to first read the value of, account A. Then after some time also, I need to read the value of account A. So now the issue is, earlier when X transaction tried to access the data, it was $300. But now when it tried accessing again, it became $400, right? So within the same transaction for X, it is reading two different values. First 300 and then 400. Why? Because simultaneously something else is also updating the database. Now this is a unrepeatable read problem, right? And is therefore known as a inconsistent read problem as well. So that is why it says that in order to maintain consistency in the database and to avoid such problems of concurrent transaction, management is needed, right? Concurrency control mechanisms are needed so that all the problems of this kind are avoided. Okay. So what is concurrency control now? Concurrency control is basically the mechanism of working on the concept that is required for controlling and managing concurrent transactions of database, and thus, in the end, avoiding inconsistencies in the database altogether. So for maintaining concurrency, we have different protocols set here. We don't have to go through all these protocols. They're out of scope for this particular course, but I'm still introducing at least the name so that you know them. Okay. So the concurrency control protocols ensure the atomicity, consistency, isolation, durability, and serializability of the concurrent execution of the transaction. So we have a lock-based concurrency control protocol, we have timestamp concurrency control protocol, and we have validation-based concurrency protocol as well. Okay, so this is all what we have, and we are going to that talked about concurrency control and then concurrency execution. Okay, and this pretty much concludes our discussion here as well. So I hope everyone is clear, right, with the overall ideas that we discussed. Concurrency control is a very important part, right? We have to make sure that multiple people do have access to the database and they are executing in such a way that, everything happens in a way so that nothing is interleaved on on top of another, and no inconsistency introduced as well. So we started our discussion with concurrent execution, what is basically it is and what is basically taking care of and why is it required. And then we talked about a few problems that can come with the two operations that are possible, read and write. We first talked about the lost update problem where some update happened, right? But since two people are trying or two transactions are happening simultaneously, that update got lost. Dirty read is when someone is doing the update and the transaction failed, but somehow the other transaction is reading the same value itself. So it's a dirty read problem. Unrepeatable read problem is that when you're trying to access data once, it's a different value. When you're trying to access it again, it's a different value. And to solve all these things, we have, I would say, different protocols put into place. Okay. So I hope this helps you to understand the overall idea. With this, we have also completed our series of transaction processing and concurrency control as well. Like I said, these are very important topics and run very parallelly with the concept of SQL as well. So please make sure you do put in great emphasis on understanding these topics as well, right? Take all the examples and then understand these concepts, because the more examples you take, the more real life examples you try to understand, the more easily the concept comes into the picture and you try to have a wholesome picture about the overall practical use cases as well. Till then, thank you so much for tuning in this DBMS series. I hope everything made sense to you and you were able to fully comprehend what was expected to learn out of this, and I could help to make this series a little bit better Thank you so much for tuning in. Thank you so much for taking a look at all the videos. Keep practicing and make sure you do solve a lot of examples. Thank you so much. Bye.